Question 4. Probability. Soft toys manufacturer continuously carries out quality control testing to uncover defects in its products. After testing a large sample of its products, the manufacturer found the probability of a soft toy having poor stitching is 0.3. So poor stitching is 0.3. Sorry, 0.03. Which means good stitching is 0.97. And what else did they tell me? A soft toy with poor stitching has a probability of splitting open 0.7%, or 0.7 of the time. So 70% of the time it will split if it has poor stitching, which means it won't split 0.3. And a soft toy without poor stitching will split 0.02, or 2% of the time. So if it has good stitching, it still could split 0.02, which means it won't split 0.98. And there's my tree diagram, which is what they asked me for in part 1. A part 2, use a tree diagram or otherwise to find the probability that a soft toy chosen at random has exactly one of these defects. So it either has bad stitching or it will split. So what are the chances that it is bad stitching only, because it said it only has one of these, exactly one of these defects. So that means bad stitching, but won't split. Or it will split, but has good stitching. Whatever. So that is good stitching and splits, so that's 0.97 multiplied by 0.02, or bad stitching and won't split. If you work that out, you end up with 0.0284, or 2.84% of the time. That's part 2. 4b then says, the manufacturer also found out that the colours used in soft toys can fade. The probability of this defect occurring, so fading now, is 0.05 or 5%. Not fading is 0.95%, 0.95 or 95%. So the probability of this occurring is independent of poor stitching or splitting, so it doesn't matter. And so a soft toy is chosen at random. Find the probability that it has none of these 3 defects. So it means that it won't fade, it won't split, and it has good stitching. Well, the good stitching is 0.97, that it won't fade is 0.95, and that it won't split. So if we go back to our tree diagram, good stitching and not splitting is 0.98. So if we want all 3 things to happen, so we have good stitching and won't split and doesn't fade. Throw that into your calculator and you end up with 0.90307, or 90.307%. That's B part 1. B part 2. Find the probability that the soft toy has exactly one of these 3 defects. So it means that it has good stitching and it splits, or it has bad stitching and doesn't split, or sorry, I forget. Here I thought we have a third thing. It has good stitching and splits and doesn't fade, not fade. It has bad stitching and doesn't split and doesn't fade. Or it has good stitching and doesn't split and fades. So back here, it has good stitching is 0.97 and it splits is 0.02 and it doesn't fade is 0.95. Or it has bad stitching 0.03 and it doesn't split is 0.3 and it doesn't fade is 0.95. Or it has good stitching 0.97 and it doesn't split is 0.98 and it fades is 0.05. And then you can just throw that into your calculator. If you throw it all in carefully, you'll end up with 0.07451 or 7.451% of the time that will happen. You'll have exactly one of these three defects.